Supabase hired me to build ClippyGPT, their next generation doc search where we can ask our old friend Clippy anything we want about Supabase and it will answer it. For those who haven't heard, OpenAI released ChatGPT, an insanely capable large language model that aims to change the way we interact with computers using natural language. But for me, I'm less interested in ChatGPT on its own and more interested in how we can use that technology in our own custom applications. This video is going to be all about this. We'll dive into a new field called prompt engineering and best practices when it comes to building custom prompts. We'll talk about the number one challenge that people face when they're designing custom prompts, plus a number of other challenges that we face when we use it in the real world, such as how do we feed GPT-3 a custom knowledge base that it wasn't trained on? How do we get past the token limits? How do you stop GPT-3 from making up wrong answers or hallucinating? By the way, who is Supabase? Supabase is an open source Firebase alternative. You can use Supabase as basically the backend provider for your platform in the same way that you could use Firebase to do that. The difference is though, apart from being open source, and the number one thing I love about Supabase is that the entire platform is actually built on Postgres, one of the leading production grade SQL databases. And why did Supabase want ClippyGPT? Well, like any good developer focused platform, providing high quality documentation is key. And if you have a big site with a lot of documentation, how do you make it easy to discover that content? Up until now, Supabase used a third-party tool called Algolia as their search service, but that only returns links back to the documentation like what I would call traditional search. Now that we have the power of large language models like GPT-3, let's improve this experience by returning the answer to the question right then and there. Okay, we're gonna get right in here. I've zoomed in my VS Code terminal quite a bit here, so those who are on smaller screens can hopefully see what I'm doing. Hopefully I don't regret this. So the way I'm going to go about this is I'm going to walk you through the different pieces of code that I've already built and basically show you what it took to build this thing. And my goal is to present this in a way that you can take these exact same ideas and bring them over to your application so you can do the same thing. So right now we're just looking at the Supabase monorepo. If you actually want to follow along yourself, Supabase is open source, of course, as we've talked about. So you can just head on over to the Supabase's GitHub organization, and then it's just their first Supabase project. This is a monorepo. It contains a couple different projects within it. One of those projects being the documentation website, which is what we're going to focus on today. And fun fact, the documentation website is actually completely built on Next.js, which in my opinion has made it a really great experience to work with. So I'm going to split the process I took into three main steps. Step one, we pre-process the knowledge base. In this case, for Supabase, this would be their documentation, which we'll find out in a second is all MDX files. Step two, we're going to store it in a database and generate a special thing called embeddings on them. And I'll explain why we're doing that and what the purpose is there in a second. And then three, we're going to inject this content as context into our GPT-3 prompt. So how did I know to go about it this way? Let's start with the number one challenge people face when they go to customize GPT-3, using their own custom knowledge base. Here's the problem. GPT-3 is general purpose. It has been trained on millions of pieces of text so that it can understand human language. Sure, it might be able to answer specific questions based on the information that it was trained on. For example, who is the CEO of Google? But as soon as you need it to produce specific results based on your product, results will be unpredictable and often just wrong. GPT-3 is notorious for just like confidently making up answers that are just plain wrong. One solution you might think would be, well, can I just take my knowledge base and insert it into my prompt every single time before I ask the question? That should give GPT-3 all the context it needs, right? Yes, it will, but you're probably not going to fit your entire knowledge base in a single prompt. Plus, that'd be pretty expensive because you are charged per token, where a token is approximately 4 characters per English word. And your knowledge base isn't going to fit into a prompt because, at least with OpenAI's latest language model today, which is Text DaVinci 3, it has a token limit of 4,000. So you need to fit everything within that token limit. You also need to treat each request as if it's a brand new context, because it is. GPT-3 has no memory between multiple requests. And by the way, if you're thinking, well, ChatGPT doesn't it? Like if I ask it multiple questions, it remembers what I said before. But that's just little tricks that it does. It's basically sending the entire multiple messages as context every single time you ask it a new question. So under the hood, it's actually just resending your old questions with it. So there are a couple of different approaches to address this, but today we're going to focus on a technique called context injection. Context injection breaks the problem down into 2 steps. Step 1, based on the user's query that they send you, you first search your knowledge base for the most relevant... Need some screen time? What do you have to say? Nothing? Change your mind? So step 1, based on the user's query, you search your knowledge base, whether it's a database or whatever, for the most relevant pieces of information that relates to their query. So if, for example, the user is asking, how do I use React with Supabase? We first search our documentation for only the most relevant pieces that talk about React. And then step 2, we inject the top most relevant pieces into the actual prompt as context, followed by the user's query itself. So this approach, as opposed to something like fine tuning, where you actually would need to retrain the model itself with your own custom data, context injection does 2 things for us. Number 1, it primes the prompt with very specific information that you want it to use within the answer. And then 2, it always uses up-to-date information, right? Every single request, every single query from the user, you would go and fetch that information from a database, which can be updated in real time, right? Fine tuning would require you to actually retrain the model every single time you have a new piece of information added to your knowledge base. Okay, so back to this. Let's take a look at the first pre-processing step and how we did that with Supabase. So open up our side view here. Under the docs project, we're going to head on down to scripts and check out our generate embeddings script. So before I can walk you through the script, I need to first explain how all the documentation on Supabase is actually built and stored within this project. So first of all, the documentation is in fact all stored within Git here. That's not stored in some external knowledge base or database or whatever. It is all within this project, and it's stored as markdown files, or specifically MDX files. And if you haven't heard of MDX files are basically markdown with JSX built in, which is pretty cool. So, you know, everything you'd expect from a regular markdown file, links, whatever, and even things like this, actual HTML tags. This isn't part of MDX. Actually, I believe this is part of GitHub flavored markdown, where it allows you to actually inject some HTML in there. The part that makes it MDX is something like this. So admonition, or let's see, do we have anything else? Not in this example. Other than down here, you can see we can actually do exports as well as imports at the top, right? So these are things that you'd expect with like JavaScript or JSX files, specifically something like this. And we're basically merging markdown with that. And for many of you, I'm sure you've seen this all the time. Pretty much every single open source project I've seen that has documentation uses either markdown or MDX. And MDX gives you a little bit of benefits where you can have some custom, nice, catered looking components within your documentation without having to like jump ship from markdown entirely and do the entire thing within pure JSX. So pretty awesome. So if you take a look here, pretty much our entire, what Supabase calls their guides, is broken down into these markdown X files. And I can show you really quick how they map, right? So I'm on the databases, or the database MDX file. And if I go over to their documentation, supabase.com/docs, they have a section here on database. So /guide/database, that basically maps one-to-one to this MDX page. And as you can see, every Supabase project comes with a full Postgres database. We get the exact same thing here. So this is the markdown converted to HTML. There's an entire Next.js pipeline that does this for us, which is great. So that's how this works under the hood. Our job now is to basically, as we said, pre-process this, right? We need to take all of this content and store it into our database. Now, I know I haven't explained exactly why we need to do that yet, right? I did explain the whole context injection piece, but I haven't explained quite yet why it's necessary to actually put that in a database as a intermediary step. But just be patient, we're going to get there. So back to generate embeddings. Essentially what this script does is, this is kind of a script that would be run during CI, continuous integration, as a step that will basically, anytime any new changes have been made to the documentation, it'll run this script that will do the step that I'm about to show you of walking through all the different markdown files and pre-processing them. So all the magic happens here within our generate embeddings. Again, I haven't explained to you what an embedding is. I'm going to get to that in just a second. Now, I'm not going to go into every tiny little detail, but I'm going to go over the high level. In case you want to do something similar, you can follow along. Again, this is all open source, so definitely reference this on your own time. But first things first, we basically grab the content, so literally a string of every single one of these markdown or MDX files. And we have a handy function that we've created called walk that will go through well, pages, literally everything here is under pages. Walk through each of them recursively and grab all the different files. That will give us a list of all the file names. And we're going to just do a little bit of filtering, such as only include the files that are MDX files and ignore some specific files like 404. We don't really need to process that one. And then we can move on to the magic. So basically we loop through every single markdown file and we need to process it. So let's talk about this processing. Why is this processing so necessary? We have this magic function, which I can show you, that basically processes the MDX content for search indexing. It extracts the metadata because our MDX files actually export some metadata that's important, similar to front matter. It strips it of all the JSX because later on when I feed this content to our actual GPT-3 prompt, I don't want it to get confused with the JSX. So for now, that's actually just getting all stripped out. And then it also will actually split into some subsections. And the reason for that is because when we later inject this as context into the GPT-3 completion model, it's better if we can work in smaller chunk sizes, right? If we only have the ability to pass in context as entire markdown files, we're limited to just that markdown file all or nothing, right? If we split that into multiple chunks, then maybe when the user has a query about React, this part of this markdown file is most relevant along with this chunk from this other markdown file, right? We can combine those together as context. So in general, this is the best practice recommended approach. For Supabase, it's nothing too sophisticated. Basically, we're breaking it down by header. So every time it comes across a new markdown header, H1, H2, or H3, it will consider that a new section and split that into its own chunk. Now, you might be wondering how we're doing these things such as stripping the JSX. Like, are we actually, going through this markdown and looking for the JSX using, I don't know, regexes or something like that? How do we actually strip out just the JSX portions? Thankfully, we're not using regex for that. We're actually getting a little bit low level and processing the markdown ourselves, which is pretty fun, actually. We're using the exact same tools that what probably most all markdown tools are using, which is tools provided by the Unified platform, right? Unified JS, these guys have done an amazing job of basically thinking about every single possible component when it comes to parsing abstract syntax trees. So basically taking things like markdown, JavaScript files, MDX files, like many different types, and creating this really nice pipeline for processing them, right? So number one, taking a markdown file, for example, and breaking it into what they're calling a syntax tree. And from there, you can actually go through every element of that markdown file and do what you want with it. So there's extensions, which is where the MDX side comes in. And we basically get our syntax tree, filter out the JSX elements, and return that. Now, worth noting right now, the solution isn't perfect, right? What about all the information that is within the JSX file? Are we going to lose that? Yes, actually. Right now, we do nothing to keep that. So that's actually a problem. We are losing some information right now. This is kind of like a version 1 broad stroke approach, whereas in the future, we'll definitely need to take a little bit more fine-grained and find a way to actually abstract meaningful content from JSX. So again, why did we do all this work? Why do we even need to process it in the first place? And why are we supposedly storing this in a database? So I think now's the time to talk about embeddings. And basically the fact that we're going to use embeddings to solve this problem is what requires us to use a database, which actually isn't necessarily a bad thing. This is somewhat cutting edge actually when it comes to the ability to do this on Postgres. So let's take a look. So I'm going to skip a little bit here. This is just a bunch of pre-checks. I'm going to explain the database in a second, but down here, we're going to get right into the embedding portion. So what is an embedding? I told you earlier that we'll be injecting the most relevant pieces of information into the prompt, but how do we actually decide which information is most relevant? Introducing embeddings. Embeddings take a piece of text and spits out a vector or list of floating point numbers. How is this useful? Well, this vector of floats is actually storing very meaningful information. Let's pretend I have 3 phrases. Number 1, the cat chases a mouse. Number 2, the kitten hunts rodents. And number 3, I like ham sandwiches. Your job is to group phrases that have similar meaning. And to do this, I'm going to ask you to plot them onto a chart where the most similar phrases are plotted together and the ones that are most dissimilar are far apart. When you're done, it might look something like this. Phrases 1 and 2, of course, will be plotted close to each other since their meanings are similar. Note though that they didn't actually share any similar vocabulary, more so just they had similar meaning, right? and that's important. And then we'd expect phrase 3 to live somewhere far away since it isn't related at all. And then let's say we had a fourth phrase, Sally ate Swiss cheese. Perhaps that might exist somewhere between phase 3 because cheese can go on sandwiches, and phrase 1 because mice like Swiss cheese. So the coordinates of these dots on the chart represents the embedding, right? In this example, we only have 2 dimensions, x and y, but these 2 dimensions represent an embedding for these phrases. Now, in reality, we're going to need way more dimensions than 2 to make this effective. So how would we generate embeddings on our knowledge base? Well, it turns out OpenAI also has an API for exactly that. They have another model, which today is called Text Embedding Ada 2, that's purpose is to generate embedding vectors for pieces of text. Compared to our example, which had 2 dimensions, these embeddings will have 1,536 dimensions. Okay, great. So we take our documentation, generate some embeddings for them, and then we go and store them in a database. What database are we going to use to store them in, by the way? Since we're building this platform for Supabase, what better platform to use as our database than Supabase itself? Now, if you're following along and you don't want to use Supabase, that's okay. The key components we're using here are Postgres and the pgvector extension for Postgres. So that's all you really need to get this working. It just so happens that Supabase has this extension along with many others built right into their Postgres image, and it's open source, so you can run it locally. How do we store the embeddings in the database, by the way? This is where pgvector comes in. pgvector is a vector tool for Postgres. It provides a new data type called, you guessed it, vector, that's perfect for storing embeddings in a column. But not only that, we can also use pgvector to compare multiple vectors with each other to see how similar they are. This is where the magic happens. If we have a database full of content with their embeddings, then when the user sends us a query, all we need to do is first generate embeddings for the query itself. So for example, if the user asks, does Supabase work with React? Then that phrase itself, we're actually going to generate an embedding on. And then number 2, we're going to perform a similarity search on our database for the embeddings that are most similar to that query. And since we've already done the hard work of pre-generating the embeddings on the entire knowledge base, this is super trivial to look up this information. If you're not familiar with linear algebra theory, the most common operations to calculate similarity are cosine similarity, dot product, and Euclidean distance. And pgvector can do all 3 of these. In the case of OpenAI specifically, the embeddings they generate are normalized, which means cosine similarity and dot product will actually produce identical results. By the way, I always want to give credit where credit is due. I just want to recognize Andrew Kane for building the pgvector extension. This is an amazing extension that I think is more relevant than ever today. And in the bit of interaction I've had, Andrew's been always super responsive and really great at keeping the extension up to date. Also worth noting, there's another extension for Postgres called Cube that is somewhat similar, but unfortunately it maxes out at 100 dimensions, which won't help us today. And there hasn't been a whole lot of maintenance on that in the last couple of years. All right, so back here, practically how are we storing these embeddings in our database? So again, since we're using Supabase as our database, which is Postgres under the hood, literally it's as simple as just using their Supabase client, which comes from their Supabase JS library. And then kind of like a query builder, you can literally just use their API to insert your data right then and there. And embedding specifically, when they come back from OpenAI's API, in JavaScript, they'll just show up as literally an array of numbers. And turns out you can actually just pass this array of numbers directly into their query builder client, and it will happily store those as proper vectors in the database under the hood. Speaking of the database and the tables there, let's take a quick look at that. I do have a migration file here. It's just from the root of the project, Supabase. If you have a local Supabase project, typically it will create a Supabase folder within your project. And then within that is where you'd actually configure the project and create things like migrations, as well as like edge functions, etc. So if we take a look at our migrations, we have for Supabase, we're calling them pages and page sections. Why do we have 2 different tables? Well, because of what I was telling you guys earlier, we are splitting our markdown pages into subsections for better context injection. So each page section would be a chunk of that page, but I still want to keep track of the pages themselves so that we can record record, for example, the path of that page, some of the metadata on that page, and then we can link the two together through foreign keys. So to actually use pgvector, you will need to, after installing it on your database, you'll actually need to call this line of code if you haven't already, which is basically tells Postgres to create this extension. In this case, if it does not exist, vector. pgvector just shows up as vector within Postgres. So that's the word we use here. We create our page table, nothing too fancy about this. And then our page section, also pretty standard other than this last line here. So we create a column. The name of the column is embedding, right? This is arbitrary. We could call this whatever we wanted, but embedding, I think, matches its purpose best. Followed by this brand new data type called vector, given to us by pgvector extension. And then the size of that vector represents the number of dimensions. So once again, OpenAI is going to return 1,536 dimensions. So that's going to be the size of our embedding vector. So pretty straightforward. Back to our code. When you're using the Supabase client, you literally just reference each of these columns within a regular old JavaScript object and pass it the information there. Now, fun fact, right now we're using this just within a script on CI, but you can actually use the Supabase client on your browser client front end to access your database. I mean, that's one of the key features here and how you would use Supabase. And if you're like me and thinking, what the heck, how is that security going to work? There's no way I want to expose all the tables in my database to be arbitrarily queried from my front end, right? It just feels wrong. But basically this client is built on Postgres. For those who haven't heard, Postgres is a REST API layer on top of Postgres that essentially will build a REST API dynamically based on the tables and columns, etc., that you have on your database, which is pretty amazing. And then again, if you're like me worried about security, don't worry, that's all covered here. Like most applications nowadays, it uses JWTs, and you actually have access to that JWT and who the current user is within Postgres itself now. So basically we're just moving the authentication and authorization logic from your own custom application API layer directly into Postgres. And understandably, Supabase is a sponsor of this, as this is pretty core to their product. So I'm going to leave it right there. Almost went down a whole nother rabbit hole there. Caught myself. If you guys are interested in learning more about Postgres, definitely let me know and we can maybe include that in another video. By the way, Supabase also has a GraphQL extension. So similar to the Postgres, you can actually query it using GraphQL. Some pretty powerful stuff there. Okay, so at this point, we've basically fully covered the whole ingestion process, embedding generation process, how we designed our database, how we stored them in the database, how we're inserting them into the database. So now let's actually get into probably the funnest part of this all, which is the actual prompt itself and the injection. By the way, there's a whole bunch of other code in here, and I'm intentionally just skipping all this. This is just a bunch of checks. We have a checksum currently on each document, just so that we're not regenerating embeddings every single time if they haven't changed. It's just kind of an optimization to only regenerate embeddings on pages that have changed. And so there's a whole bunch of extra logic around that. So to do the completion, we do have a backend API route that we've created. Since we are using Supabase for this, naturally we used a Supabase edge function. I'm going to stop myself before I go down a huge rabbit hole into edge functions. Basically, it's a serverless function, so super common these days, available on many different platforms, and Supabase has their own version. Fun fact, Supabase's edge functions use Dino under the hood, which is kind of like a newer alternative to Node.js, built by actually the same original creator as Node.js when he decided that there's lots of improvements that he wished he did, and that's what Dino is. So if you've never used Dino before, very similar syntax to what you do in Node.js, just with a couple changes, especially around imports and environment variables. But let's scroll down to the meat of this edge function. First thing we do is OpenAI actually has a moderation endpoint. As part of their terms and conditions, they actually do require you to make sure that the content that you're sending in complies to their guidelines. So like no hate language, stuff like that. And since we're letting users dynamically put anything they want into this, we need to run it through their moderation API, which is free. If it passes that, we come down, we create the embedding. Remember, we need to create a one-time embedding every single request on just the query itself, right? We need this embedding so we can use that to find the most similar content from our database. And I'll show you how that similarity function works And I'll show you that right now, because that's next. A couple ways we could have gone about this. Number one way would be if I was actually just using a pure Postgres SQL client, which you can do, by the way. When you use Supabase, you're not locked into just using their libraries. They actually expose the Postgres database externally, so you can connect directly to it from your backend. So we could have done that and then just wrote some raw SQL or use something like Connect.js to write our query. But instead, just to keep things a little bit simpler, we're going to continue to use Supabase's JavaScript library, and they have a special function called RPC, which essentially allows you to call a Postgres function, right? So for those who don't know, Postgres itself is actually able to have functions, which I can show you right now. So basically, we're going to create a function called match page sections, and it's going to have a couple different parameters for it. And the way we design this function, it's going to return basically all the page sections that are relevant, right? In this case, only give me the top 10 best page sections that relate to the user's query. So this function's in a second migration here, and we call the function match page sections. This is how you would design a function in Postgres. Essentially what we're doing here is it's just a simple select query where we're returning, in this case, we're doing a couple things. Since we have this relationship between the page section and the actual page itself, we're joining those tables just so that we return the path. And that path is going to be useful down the road when we want to actually provide links back to this content. We're also returning the content itself, the most important thing here, so that we can inject that into our prompt. And then we're actually also just returning the similarity. So how similar this piece of content was to the original query. And we're getting that from this operation right here. As we briefly talked about earlier, pgvector provides us a couple new operators. This specific one is the inner product operator, and it's actually negative by default, just the way that Postgres works. It's limited to sorting the result of this operator ascending only. So the assumption when pgvector was created is that, well, if it's only going to return it in ascending order, we need to negate the inner product so that the most relevant ones come first, assuming that we're trying to match for the most relevant, right? So here to get the actual similarity, we're just multiplying by -1 by the time it gets returned back to whoever is calling this function. We also just have a handy parameter called match threshold that you can use to actually filter the results to only include page sections that are at least above a certain threshold. Of course, we need to order by the similarity there and then limit it by this match count, which we're also passed as a parameter. So hopefully that's pretty straightforward. Side note here, I had to throw in this variable conflict use variable. All this means is since we're reusing the word embedding as a parameter variable, but also as a column on the page sections, by default, Postgres will consider that a conflict. So I'm basically saying, hey, if you just see embedding by itself, assume it's a variable. Otherwise, if I'm explicitly prefixing the table, then of course that would be the table. So if you're wondering why that's there, that's what that's all about. So since we've kind of hidden all that fancy logic into a Postgres function, again, back here, we can just use the Supabase client to do an RPC. RPC will look for exactly that, Postgres functions. We pass it in the name with these parameters. Again, we can just pass the resulting embedding directly into this function and it will work. And the result will be our page sections. And now's the fun part. Now is when we're actually going to take this content and inject it into our prompt, and we're going to talk about the prompt itself. This part I'm going to breeze over real quick. GPT-3 tokenizer, this is coming from another library that will basically tokenize our content. I told you earlier that when it comes to GPT-3, everything is token based, and in the English language, every 4 characters approximately is a token. Not a hard rule of thumb, but if you had to generalize. But if we can actually calculate the real number of tokens, that can actually be quite helpful here. And so we're actually doing that here. We're actually taking all of the content and parsing out the tokens from them and then calculating the size. And the reason why we do that is just so that we can limit the number of tokens in this query, right? Number one, we have to limit ourselves to be within that 4,000 token limit. And this also just gives us the opportunity to kind of fine tune how much context we actually want to pass in the first place. Okay, next here we have the prompt itself. So first thing I want to mention is this is literally as simple as it gets. No fancy templating language. Literally, this is just a JavaScript template literal, and we're just passing in our template variables directly here. The indentation looks weird just because we don't want tabs at the beginning. Fun fact, if you wanted, there's a library called Common Tags that actually give you some really nice template literal tag functions, and some of those can do like stripped and indentation. So if we really wanted to, we could have used that to still indent this nicely and it would strip them. Not going to go down that rabbit hole right now, but just a fun fact. So let's talk about this prompt. What I want to cover with you guys is just a little bit of prompt engineering best practices and kind of the reason why I engineered the prompt in this way. And the best way to visualize this is probably if I copy this into another tool called prompts.ai. Full disclaimer, this is a tool that I'm working on. You can think of prompts.ai as the JS fiddle or the code sandbox of prompt engineering. So you can come in here and create your own prompt with placeholders, inputs, test it out, and actually save it for later and share the link with people. And the aim is to be a platform where we can all collaborate together on our prompts. Lots of features planned. Right now it's just simple freeform text input, but we're going to add different schema types there, and even the ability to use embeddings themselves, the ability to test a prompt and save those tests, etc. But let's stay focused. So I'm going to replace this prompt with the one that I just copied from the clipboard. Placeholders here are just done using 2 curly braces. So let me just like that, and there's our prompt. So let's read this out loud. You are a very enthusiastic Supabase representative who loves to help people. Given the following sections from the Supabase documentation, answer the question using only that information. Output it in markdown format. If you're unsure and the answer is not explicitly written in the documentation, say, sorry, I don't know how to help with that. And then we have this label we're calling context sections, followed by a placeholder for the context text. And then we have the question itself. So we have a label for that, followed by placeholder for that. And then we finish this off by saying answer as markdown, including related code snippets if available. And then we have the completion, which completion just marks where the GPT-3 will complete this prompt. So down here, we can actually type in our input. So if I actually took real context from the documentation, this is where I'd paste that. Of course, we're not manually doing this. All of our code back here, as we just described, is dynamically fetching those pieces from the database using embeddings. That's the whole point of this. And then it's injecting that dynamically there. But you can imagine that's what that's for. And then this is the sanitized query. I think we sanitize the query just by, take a look. Right now we're just trimming it. So very basic, trimming the white space from the ends of it. But this is likely to get more sophisticated down the road. So here you can visualize, right? Let's just pretend there's a piece of documentation that said, well, let's not pretend, let's actually check out the real docs. Okay, so I'm on the pgcron docs. pgcron is an extension for Postgres built into Supabase that allows you to do cron jobs. So here's an example of code snippet, right? So let's pretend that, the user asked a question like, how do I create a cron, right? And with our embedding saved in Postgres, let's say that our algorithm came up with this code snippet. Likely it's going to come up with a bunch of these, but for now we'll keep it simple. Came up with this code snippet and maybe that text on how to, in this case, delete a cron. Well, okay, let's do run a cron. Maybe that's a bit more practical. Copy that. When it gets pasted in here, we actually do keep the markdown formatting. And actually, speaking of markdown, turns out GPT-3 is really good at both understanding markdown and actually creating markdown too. And you'll see a little bit later, but this is basically how we're able to produce these really high quality responses that look really nice, is because we're actually getting GPT-3 to output markdown itself that we can display nicely using a markdown renderer. So back here, let's artificially add that back in. This would be a SQL code snippet written in markdown. So this is how it would actually get injected right in. Again, with some other sections, we'd be able to fit more than just that in there. So if we fill in those inputs, we can visualize how the prompt will actually get sent to the completion API. Down here, you can just adjust which family and model is being used. DaVinci 3, as we talked about, is the latest today. As more models come out, we'll be able to use those, or as more families come out from different organizations, we can test out different models. Let's go ahead and run this. And there's a response, right? You can create a cron using the cron schedule method, such as the one below. It's actually outputting markdown once again. In this case, I think it almost basically just copied that one directly. But check this out. This cron sets a daily recurring job called vacuum at 3 a.m. GMT each day based on that. Now, notice we didn't actually talk about that. So this is where the actual generative language model is becoming very powerful, right? It's doing some extra explanation that is very useful here, and it just deduced this on its own. So at this point, we would take this completion and return this back from our edge function to our end user. And since it is spitting out markdown, right, as we talked about, now anywhere we have markdown, like the inline snippet there or the multi-line snippet there, we can actually now run that through a markdown renderer and get some really nice looking results. So before we finish the video, where I'll quickly show you the front end side of all this, let's just quickly break down this prompt and talk about some of the components and why I chose to build them that way. Now, disclaimer here, prompt engineering is an emerging field. So some of these best practices are guaranteed to change and improve over time. But for now, this is kind of the aggregation of some of the recommended approaches today. So first thing we do here is we actually give the model a identity, right? You are a very enthusiastic Supabase model who loves to help people. What does identity do? Well, it's priming the model so that it understands its purpose prior to us giving it a task. By saying very enthusiastic, we're hoping that this will help, at least at a minimum, make the model as cheerful as possible, use exclamation marks, things like that, when it makes sense to. Also, by saying this is a Supabase representative, now any kind of possible query that the user sends, the answer provided will always be within the context that it was created from a Supabase representative, right? So after identity, we go into task, right? Given the following sections from the Supabase documentation, answer the question using only that information, outputted in markdown format. So this part is very important. It's the instructions for the prompt. This is what I'm asking you to do. We want to improve the likelihood that we get the kind of result that we want. This next part here is what I'm going to call a condition. So if you are unsure and the answer is not explicitly written in the documentation, say, sorry, I don't know how to help with that, right? Without this section, this is where we are in danger of GPT-3 hallucinating. Hallucinating is a term we use when GPT-3 makes stuff up. And as we already talked about, GPT-3 is notorious for just like confidently giving you the wrong answer, especially when it comes to math, I found, right? It's a language model after all. So any kind of like math operation, it's not amazing at, but it will confidently, very, very confidently tell you that it thinks it knows the answer. You can even give it a math equation, ask it for an answer, and then also ask it for like its confidence level, 1 to 10. How confident are you that this answer is correct? And then it will proceed to give you like the wrong answer and then 10 out of 10 confidence, which is hilarious. So when you're creating a prompt for your own custom application that's going to represent your product to end users, you want to make sure that you have a condition in there to prevent the model from saying something you don't want it to say about your product or just making something up entirely, which are both bad things. Next, we have the context. So I would call this part of the prompt literally the context itself. This could either be manually entered in or in our case, dynamically injected. Again, this practice is called context injection, but it is just another input after all. The thing right above it, we're calling labels, right? Labels help give the prompt structure. So not only have we given it a task, but now we're reinforcing that task by saying, here's the context that I told you I was going to give you. So label, context. And then here is the question that I told you I was going to give you. Question followed by the query. Now, what's with these triple quotes? This is something that is recommended just to make it very explicit to the model what your question is. Right now, OpenAI has recommended something like 3 quotations, triple quotes to do that. And the other thing this does too is potentially can help with prompt injection as well. So if people try to start to ask this prompt to do something that's outside of the scope of what you want it to do, in this case, if they're trying to ask Supabase to answer something that's outside of the scope of something related to Supabase, keeping it within these triple quotes can, at least at a very basic level, help with that. And then finally at the end here, we have our final label, which we're calling answer. So answer as markdown. So again, reinforcing that we really want this answer to be formatted as markdown, which in my experience, it's done a very great job of doing. And then this was added on later. Include related code snippets if available. For Supabase specifically, code snippets and examples are some of the most useful things in their documentation. So we just wanted to give it a little bit of help, a little bit of that extra hint to, if the context that we injected here had any kind of relevant code snippet to their query, include that if possible, because we encounter certain situations where they were available, but GPT-3 just decided not to include those. So things like this are just little hints you can do to help coerce the model to give you something a little bit closer to what you're looking for. I did write a blog article on all this stuff. I could throw that in the video description if that's helpful. Feel free to check it out. Basically, just what is prompt engineering? It goes into some of these things and lets you actually try out a couple of the examples in the playground here. So prompt has been covered now. What's the last step? We're just using OpenAI's library, again, to call the completion endpoint, passing in the model, this prompt that we've crafted, the maximum number of tokens it should respond with, which you can control. And in this case, we set the temperature as well. I'm not going to go super deep into temperature, but think of temperature as how deterministic you want the answer to be. So temperature of 0 means given the exact same prompt multiple times, it will produce the identical response each time. Whereas any temperature greater than 0, the higher you go, the more varied that response will be. And depending on the situation, sometimes that variance is good. In our situation, we preferred to keep the responses consistent if the query was consistent. Setting the temperature to 0 also helps when you're testing different scenarios. It makes it a little bit easier to help craft and cater your prompt. And then at the very end, we're returning it back to the user. So this video would not be complete without me showing you the end result. So let's take a look. So here we have it, guys. We have our good friend Clippy in the bottom right-hand corner here. Something I want to note is the user interface that I'm showing you right now is almost guaranteed to change and improve over time. I've been working with some very talented designers and front-end developers at Supabase, and they're just doing an amazing job of making this thing look awesome. Oh, and by the way, I want to mention for some of my followers, a lot of you guys watch my Blender videos, so I just had to mention Clippy was in fact made in Blender. So here he is, just whipped up a little model of him, of course with a Supabase customization there. Super fun building and animating him. But back to this, let's show this thing off. So first things first, we can click on Clippy's bubble there. And like we talked about, the whole idea is we can simply use natural language to ask, in this case, Clippy, anything we want. And ideally, it will respond right then and there like ChatGPT would, but catered to be about Supabase. And now that you know how the entire thing works in the backend, let's take a look. So let's start off with a simple one. How do I run migrations? And okay, check it out. You can run migrations by using Supabase's CLI. So Supabase migration new employee, for example, and it walks you through those steps. Of course, it's using markdown snippets here. This fully integrates with Supabase's existing markdown styling and components. And even links will work here as well. When you click them, go straight to the documentation. So another thing you can do, which is quite powerful now that we have a generative language model, is give it something a little bit custom, right? So for example, if I said, how do I create a migration called sandwich table? Assuming that I wanted to create a migration to create a table about sandwiches. Let's see what it says. All right, check it out. So we got something similar, but this time we have sandwich table placed everywhere instead. And it even gave us a sample sandwich table, which is kind of neat. What else can we do? What if we said, how do JWTs work in Postgres? So there we go. It talks about how Supabase creates users in Postgres, how it will return a JWT when it creates the user for the first time, etc., etc. So once again, under the hood, what happened here is we took this query, generated an embedding on it. It searched our entire database, which is pre-processed with all the documentation from Supabase, with an embedding that matches this query. It found the top most relevant chunks of content to this query, and then inserted that into our prompt as context, followed by this query itself. And we basically let GPT-3 do the rest and use that context to give us a catered answer right here. Let's do one more. Does this work with Next.js? And there we go. Yes, this works with Next.js. So potentially that enthusiastic part of the prompt is contributing here. And then it goes to talk about the Supabase auth helpers, and they have a specific one for Next.js, which you can even copy the install command right then and there. Pretty awesome. So that's it for today. Thanks for following along. I also want to mention that it's been an absolute pleasure working with the Supabase team. Props to Paul and Ant and the entire team there for building a great product. I love how just everyone on the team jumps in and helps out where they can. And it's made a project like this really enjoyable to work on. Thanks so much for watching today, guys, and I hope to catch you down the next rabbit hole.